Very good morning, everyone. So today again, we are back to the class and welcome all of you to the class. Let me enable my sharing of the screen so that you can see and discuss all that. Fine. So, well, uh, let me just start with the writing mode. Yeah. Okay. Ready? So last time we have already discussed a lot of concepts related to sorting in linear time. I hope you have worked over that. And sorting in linear time, as you remember, last time we have seen first the corresponding counting sort. And second, what we have used is already radix sort. And I told you last time that this time we are going to start with another one, which is called as a bucket sort. So today we are going to see the bucket sorting algorithms working and the corresponding program. But of course, we always say there are conditions apply, like whenever there is sorting being done in linear time, it's not a generic algorithm. It's not possible to implement it on every kind of a data. So what effectively it requires is there will be certain restrictions on the data. And in every newspaper or everywhere, whenever you see that, yes, you can double your money in 2 years or 1 year or 3 months, then smallly you will find a star mentioned conditions apply. So here also conditions do apply. The two conditions which are here, the first condition is that the values are in the range of 0 to 1. So effectively, these are the fractional values. This means excluding 1, and this square bracket means including. So you are well aware mathematically these are symbols. So all values are something like, say, 0.001 up to maybe 0.9999. All these values are the range. Although we will have the ways and means to relax this condition in some mechanism. And the second important condition is, so this was, I'll say, condition first. And the second important condition which will be applicable in this case is that the values are to be randomly generated randomly, but uniformly distributed also. So they are generated randomly. That's one thing. Random is okay. And uniformly distributed. Why do we need this condition and why we are talking of this? Yes, we will understand within the discussions of this topic. But effectively, uniformly distributed, etc., you have already studied in mathematics the probability distributions and the relevance of all these random variables. Primarily or loosely speaking, I can say uniformly distributed will mean that the values are not clustered into a single particular small range. So if I'm saying that the values are in between a range of almost near 0 and this being 0.9999. So if I say that there are n values, say n equal to 10, let's say, so it doesn't mean that all 10 values are somewhere here, or all 10 values are somewhere here, or all 10 values are clustered into a single area. I mean that they are equally dispersed. Approximately, they are distributed uniformly over the total region. That is what we mean. So these are the two conditions. Knowing these conditions, algorithm is very simple. It says that I have n buckets if there are n values. So if I have n values, there are going to be n buckets. N buckets will be present within which the data will be stored. And so we have extra space complexity that is expected also in counting sort also. We have extra space complexity, radix sort also, similar concept applicable. And here also you can easily expect that nothing comes for free. There is something known as a no free lunch theorem. So obviously, whenever we are able to improve time complexity beyond a certain limit, it will be always possible by having some additional space complexity. But as we are more worried or more interested to get linear time sorting, so we will be comfortable to have some extra space complexity. But on average, if you say that there are n values, and if there are n buckets, so approximately you can say one value per bucket we can expect. So that's something to remember. Of course, it won't be one always. On average, I can say, but this might not be always true. But at the same time, I can say that bucket size is not going to be very large. No bucket is going to be of the size n by 2 or something like that. So no bucket will be of some big size, will be of some size, say n by 2 or n by 4 or something like that. They are approximately small buckets and they will be useful for the storage. Now, effectively, bucket sort algorithm is very simple. We are not going to do something great. Algorithm's crux or main logic is simple, that I will have multiple buckets. So I say there is bucket, this one available. Say I say bucket 0. Similarly, I have bucket 1 and so and so. There are total n minus 1 buckets. N buckets, last being bucket n minus 1. Let's assume I have values, say 0.03, 0.98, 0.57, 0.33, 0.52, 0.64, 0.93, 0.67, and maybe let's say 0.51. So, and there are many more values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's assume one more value. So maybe let's say 0.25. So now I have total n as a 10. So I have 10 buckets also available. The algorithm's working simply says start with the first value, say 0.25, and I am going to put it into the corresponding bucket. So each value is supposed to go into a specific bucket. How the bucket number will be found? The bucket number will be always n into ai. If the ai is a value, I'll say n into ai and floor of that. Floor of that will mean this. For example, if in this case 0.25, so I said 10 into 0.25, that comes out to be 2.5. Floor of that means value index 2. So this bucket will be used to store this value. Of course, if n is different, for example, n equal to 4 will mean accordingly I have total 4 buckets. Approximately that will mean bucket 0 to have values of the range of approximately 0 to 0.25, and similarly bucket 1 to have the value in the range of 0.25 to 0.5. You can easily see that effectively each bucket is being given a range to store, and accordingly, if there are total 4 buckets, so my total area is divided into, or my total range is divided into 4 different sub-ranges, and then accordingly, each value belonging to that range is supposed to go to one specific bucket. So if n equal to 10 effectively means that my bucket 0, I have this bucket 0 effectively mean 0 to 0.1, loosely speaking, and bucket 1 having values 0.1 to 0.2. Similarly, bucket 2 being 0.2 to 0.3, and so and so up to bucket 9 effectively having 0.9 to 0.99999. Keeping n as a 10 makes the things easier to understand. Effectively, that means the first decimal place after decimal first digit is straight away telling the bucket number. So taking n as 10 as an example makes the things easier. This means this go to second bucket. So in the second bucket, initially bucket is empty. I'll get 0.25 here. 0.03 supposed to go to this bucket. 0.98 supposed to go to the bucket number 9, index 9 rather, 10th bucket. So that will mean 0.98 coming here. 0.57. I'll concentrate on, let's say, bucket index 5 because I have 3 values here. So 0.57 will go here. Then comes a 0.52. So ideally, I'll keep the 0.52 here in the bucket. How the bucket will be arranged, we will see. For the time being, I am assuming that it has some space available for the storage. And later, I'll get 0.51. So that also value, let's for that assume this value is 0.54. So let this value be 0.5. The purpose of taking 0.54 is all these values are currently not sorted. So bucket will get many values and we are going to have some arrangement. Ultimately, so once all values are shifted to the bucket, that will become my first step. So I can say first step will be insert all values into proper bucket. The specific bucket. And the which specific bucket? The bucket number I know. I can calculate mathematically. Then second step is now, as some of the buckets might have more than one value, on average one, but as we could see in the index 5 bucket, there are 3 values, and probably bucket with index 4, that is values with 0.4 onwards are null. So there is no bucket and no value in the bucket index 4. Similarly, no value in the bucket index 8. I can easily say no value with 0.8 something, no value with 0.4 something. So I have these values. Accordingly, some of the buckets will be empty and some of the buckets will get multiple values. For example, I have taken that I could get multiple values into my bucket index 5. Similarly, for bucket 9 also, I will have more than one value. And accordingly, all that. So now the logic comes, each bucket will be sorted using insertion sort. And using insertion sort, there is a specific reason why we are choosing insertion sort to be done. We will understand maybe after a few minutes. Once each bucket gets sorted, so I can easily see these values will get arranged, let's say as 0.52, then 0.54, then 0.57, and this will be my bucket 5 starting as. Then, now effectively, if all buckets are sorted, my results are ready. I can easily see that my result is nothing but all values of a bucket 0, followed by all values of bucket 1, followed by all values in order of bucket 2, followed by in between all, and similarly all values of bucket index 5. That will mean these values now, and accordingly everything happening like this. So I'll say first step was already there, where I said insert the value into the bucket, each AI effectively. Second step I said is I'm going to sort each bucket using insertion sort. So I said each bucket will be sorted. Sort each bucket using insertion sort. And third step now comes, concatenate all buckets in that order. Concatenate all buckets in order. And that effectively makes the sorting O. Now, looking at this example and these discussions, there are few important observations. First thing, that why did we have the range of fractional values? We said that fractional values in the range of 0 to less than 1, 0.9999. So I had these values. Why? Now you can easily see the advantage of this is that bucket number could be easily identified as a mathematical expression as n into ai. So, but I can easily see that if I am somehow able to find bucket number in unit time, then finding and shifting the value into each bucket, one value shifting will take only one step, and this step will exactly take a theta of n time. So my step one will take theta of 1 time. Step one will take theta of 1 time for each value. So overall time will be theta of n. Then comes second step. Now this is an important step. We know that insertion sort in worst case is going to be really time consuming. But for insertion sort, theta of n square in worst case, we know is the time complexity. But that is when the values were in each bucket as n, or values were n, count of values. In this case, each bucket has very less values. Less values. And so I can say my total time for step 2, which is the sorting of each bucket, will be nothing but, I'll say I equal to 0 to n minus 1. Maybe I can say order of ni square, where ni is number of values in bucket bi, in bucket number I. And I can expect normally on average, we have already said ni is approximately, in best case, I'll say, if I have the perfect uniform distribution, each ni is going to be 1. On average, I can say may not be 1, could be 2, 3, 4, 5. If n is 5,000, maybe if I have n is 5,000, I have total 5,000 buckets available. So by each ni, maybe could be sometimes near of range of maybe 1 to 10. I can expect if the uniform distribution was there. So now you can easily see why did we talk of uniform distribution? Because uniform distribution will ensure that my ni will never go beyond a certain range. As long as ni remains within the limit, then I can easily see total time for step 2 will also remain in the order of n or theta of n. And then I can say third step, concatenation. Ideally, I should be able to concatenate again in theta of n steps. Then should be the aim. If I am able to do so, so I will say my total time complexity will be theta of n for step 1 plus summation of ni square step 2 and maybe theta of n step 3. Why step 3? Again, I am claiming theta of n. I will just understand. But if this value is O of n or theta of n, then I can say overall the time complexity will be theta of n. This can be proved mathematically using concept of expected values, and based on that mathematical calculations, you can probably prove this. If the uniform distribution was existing, this will be possible to get it into theta of, well, n. So I can say this will be possible to get in theta of n or big O of n, and that you can always prove. For more detail, read the Corman's book very carefully, and there all this is described. You must read that so that the mathematical conceptual clarity is there, and during interviews, if that is discussed, you are knowing that knowledge, not just knowing the programming, but also being conceptually sound in that concept. So must read that also, you should practice. Then, now I talk of step 3, related and concatenation and related issues. So now the question comes, how concatenation will be done? A bigger question comes, how buckets will be arranged. How buckets will be arranged, that is going to be another big question. Will be stored and maintained. Will be, I'll say, stored and used. So ideally, the researcher who suggested bucket sort, he said bucket should be as a linked list. As a linked list. And why linked list, we will understand. But what he said was that I should have bucket to be declared. I'll say, let me just remove this so that I can have a better line. Yeah. So I say I had, for the time being, bucket 0 to bucket n minus 1, each of them as a point. So B is effectively array of pointers. And each pointer is pointer to a linked list. So when I initially said that I have values 0.0, 0.33, 0.002, 0.57, 0.99, 0.52, 0.54. So now effectively 0.33 will go to 0, 1, 2, 3. So here I will have 0.33 stored. For the time being, this will be null. 0.02 coming here. Earlier, this list was null. Similarly, this is my list 5. So initially, I will have here null list. Then after null list, we will be able to add here 0.57. Later, we will be able to add here, say 0.52. Later, say 0.54. And null. So accordingly, all linked lists will be available. And then the advantage, or why this is, why linked list, the reasons can be understood easily. First, no wastage of space in buckets. See, if you say comparatively, if you say you have alternate is, you use it as a 2D array. So you declare it as a 2D array. 2D array will mean that you have each bucket as another 1D array. So I say Let this be B0. Let this be B1, B2, and so and so. But we need to decide here how many values. Size has to be known. If I use this as a 2D array, maybe I have to say something like as bucket of, let's say, 5,000 into 10 if n is 5,000. If n is not known, maybe you can have a dynamically malloc done and decided. But for each of the bucket, how much will be the memory? For simple programming, we will be forced to tell how much size. And we don't know whether they will get 1 value or 2 value or 10 values. Some of them will get even 0 values. So in this case, normally there are 5,000 values, but we allocated space for 50,000 values. 10 times more space was allocated because we assume the maximum 10 values in each bucket, but you don't know. Ideally, out of 50,000, only 5,000 will be actually used. So there is a too much of a wastage if I go for the corresponding 2D array. So I can easily say, using linked list, only 5,000 nodes will be exactly allocated, where 5,000 is the value of n. Values or 5,000 nodes will be stored. Of course, a node will have some extra memory compared to a normal value. So that is always an issue with the linked list. But still, I can say now there will be only 5,000 nodes will be stored. And hence, I can probably save memory in wasting for not pre-determining and pre-reserving more values for each bucket. Any bucket empty, no value will be stored at all. Some bucket gets 5 values, correspondingly 5 nodes will come and like. So all that will happen in this particular manner. Secondly, so that becomes one advantage. Secondly, insertion sort becomes much more simpler using linked list. Simple and easy using linked list. Why? The biggest advantage is, in case of array, you have to do the shifting of the elements to create a space. In case of insertion sort, if you are doing insertion sort over an array, that will require that you have to shift elements. For example, if you had values, let's say 50, 60, 70, 80, and now you wanted 40 to be put or inserted into this using insertion sort, then actually this requires that you have to shift your values 60, 70, 80 to right side. Earlier they were like this, but now you need, or I'll say rather, all values up to 50 to be shifted. So effectively they all to be shifted to this place. That requires, first of all, 80 to be copy paste, then 70 to be copy paste, then 60 to be copy paste, then 50 to be copy paste. Now you have to create a space here. And then once a space is created, then you could store 40. So this worked like this. In case of a linked list, this will not be needed. No shifting or copy paste needed. So you can directly insert value into a linked list without any shifting requirements. That is the advantage of linked list. Thirdly, concatenation will become much simpler if you use this particular concept. Concatenation of n linked lists will be very easy. Effectively, it will mean bucket 0 is one linked list. So you have this linked list. Wherever it is ending, you have similarly, you have bucket 1 as a linked list. You have to do nothing, but you have to simply come and connect like this. Similarly, say this was null. You have to simply go and connect to, say, bucket 2, and so and so. So guaranteedly in theta of n, I will be able to do this concatenation. To be precise, I will say it is a big O of n because last bucket list need not be traversed. That will be just connected and over. So even that will not be traversed. Otherwise, this all will get traversed exactly once. There are total n nodes exactly. All nodes will be traversed exactly once, except the last bucket list. And of course, that will mean the concatenation will be possible in big O of n. So all that becomes easy. Then continuing further, lastly, few minutes of discussion now needed to understand that if you know pointers, then you must do like this. If you do not know pointers or linked list, so at the time being, for the time being, you might find use linked list and implement bucket sort. But if you do not have good knowledge of linked lists, for the time being at least, you should try using 2D array. If you don't have good knowledge of linked list, use a 2D array for the time being. Of course, this is not a good way, but ideally, bucket sort means you have to use correspondingly the linked list on. But if you use it, if 2D array is used, of course, you can assume some upper limit. So bucket size, you can assume, let's say 10 or 15, say assume bucket size as, say, maybe let's say 5 or 10 or 15, and that's it. But say that will mean effectively you have, say, all buckets to be of the same size, whether you show it vertically or show it horizontally. So I'll simply say one and the same thing. So I could say, let's remove this and use it horizontally the way we earlier discussed. So I say, this is my bucket 0. Based on the size, you will have correspondingly values. Then you have bucket 1, and so and so. Now, in case of linked list, null could tell how many values were there for knowing the size of the each bucket list, size of the linked list. If you use array, how many elements are in bucket 0? No idea. How many elements are in each of the bucket? How do you know that? So that is also not sure. So you have to do some arrangement. So maybe you can take another temporary array as sizes, where sizes 0 will tell, size 0 will tell number of values in bucket 0, number of elements in bucket 0, and so and so. So by using this, you will be able to have extra array. Of course, all this is adding to space complexity. All this is not a good solution, but not an ideal solution. But for simplicity, for the time being, you can do like this. But practice will be possible, and using array you can implement for the time being. So I'll show you a sample code for the corresponding scenario, using which you will be able to use all these things in a good way, and then you will be able to have the same practice done. So I'll share with you a bucket sort sample code. For example, I say, if I have to implement my bucket sort effectively, this is what I will do. You can easily see, first thing is I will declare certain number of buckets. So I assumed maximum 20 buckets, each with a maximum size of 15, let's say. Of course, you can take much lesser size also. Then I assumed a sizes array, and where you could initialize that value with the 0. Then I would, instead of going for fractional values, I'm using the concept of any values in the range of 1 to n. Let's say n is 1000. So I will say 1 to 1000, total 1000 values. And in that case, if I say there are going to be total range is 1 to 1000 and total values n is 10. So I mean each 100 values should go into corresponding bucket. Values 1 to 100 should go into bucket 0, 101 to 200 in bucket 2, because the range of the values is 1 to 1000. Total values are 10. I assume uniform distribution will mean 1 or 2 values in a range 1 to 100, 1 or 2 values in range 101 to 200. So n equal to 10, range being 1 to 1000, I expect my each bucket to contain values in the range of certain 100, 1 to 100, etc. So I will distribute my total range of values into n buckets. So how do I find that? I will say in the main, I will decide dividing factor to be equal to range divided by n. And by this process, you will be able to find out the total bucket range. And using this, you will be able to have that. So going on this, you will have 3 steps. I will say how to insert, find out the bucket number. Now, mathematically, bucket number should be possible to be calculated in unit time. You can think of to do how. Then I would like to store the element into corresponding buckets. And so I should know how much is the K. K you should calculate. K is directly relevant to the corresponding size array which we have maintained. And once you have done this, then you should sort each bucket using insertion sort. So you should have the insertion sort logic effectively used here. And once it is done, after that, you will be able to concatenate all these buckets and then display the results. So this is the way I should be able to implement all of these implementation for the bucket sort. Just let me check if I have time. Let me just complete. I think the meeting might just end. So I'll just quickly show you the code related to the counting sort. I hope you have implemented already. Last time I told you, and today I'm going to show you the sample code for the counting sort. So I assumed here the K as 9. So there are going to be total 10 different indexes available, 0 to K, 0 to 9. I have used the same variable B for storing the values. The correspondingly, each value will be first of all found. So you can either write here val equal to AI and then B counting the total number of values in the array with value, let's say 0 with value 1, with value 2. So whatever counting sort logic we discussed, we can directly write here also that BAI++, that is also one and the same thing. But if you don't understand why we are not able to, how we are able to do this, so you can otherwise also, you can say, fine, no problem. You can easily write it. Okay. So just let me have. So you could write like this also. It is one and the same thing. You can safely write like this. But if you get confused, no need to bother about this. You can straight away use. Then finding the cumulative total for each of them. And then going to find out where each value is to be stored. So first of all, I find the corresponding value. Then the index, the ending index of the corresponding value is found using this. And then I'm able to find the index position. Using C in that index, I will store the corresponding value. And now ending index for the corresponding value will be decremented. This loop is a downwards from the reverse side we have started. As we discussed that it will require some kind of stability ensurement through this process. Normally, we always prefer to have the values stored in form of the original array being sorted. So I have given here the copy back. Otherwise, this is not compulsory. Quickly showing you the code for the radix sort also. Effectively, radix sort meant that I'm going to call the radix sort for multiple times. So I try to find out the value, which is the maximum. From there, I will get how many total digits are there. Those many times I will repeat my program's loop, and each time I will call the count sort. Exponent will be increased by 10, so total number of digit times it will be repeated. With the count sort, the only change is I'm also sending the exponent using which the digit is to be extracted. As we have said that radix sort, we will start extracting the digit from the least significant and going towards most. So here, the same counting sort logic, whatever we have discussed, but with a change that I'm able to find out the corresponding digit via this logic. In the last class, we have discussed that this we have to find out mathematically. So this can be one of the way to find which digit is being used. Find the position using that digit. Rest of the total value will be stored in totality. The only digit is not stored, full value will be stored. So this is the way radix sort can be run and can be implemented. So you should be able to do this. How to find out the maximum value? So I'll just read the values, then call radix sort, and here I can have a get max, which can calculate what is the total maximum value, and then using this max, I will be able to find max, and then total number of digits will be extracted for this. Any questions, any doubts are welcome. Otherwise, definitely we are going to wind up. Zoom might be just ending up with the time. So I'm just stopping my sharing of the screen and stopping all this recording.